Our speaker tonight is Dr. Emily Bartz. She's a station archaeologist for Pine Bluff with the Arkansas Archaeological Survey at the University of Arkansas. A recent graduate of the University of Florida, she specializes in the study of ancient pottery and cooking techniques. Her research integrates experimental archaeology and organic residue analysis to uncover insights into past culinary practices in the daily lives of ancient communities of the American Southeast. So thank you, Emily. Let me
Thank
stop sharing my screen and let you take it away.
All right, and I'm gonna start sharing my screen. Holler if you can see it.
Looks good.
Yep. All right, very good. All right, well, thank you for the introduction and thanks so much for inviting me here today. I'm going to be talking to you guys about my dissertation research tonight, and this includes three major topics. So if you have big questions at the end, that is quite understandable because I'm covering a lot in a short period of time. So first and foremost, I'm studying North America's first pottery, and this is called Stallings wares, just from the Stallings culture. And a little bit about why archaeologists are interested in pottery as well. One, it lasts a really long time, and two, you can tell a heck of a lot about the people that were making it just by studying everything about it. So its shape, its forms, what materials they used, how they fired it, how they decorated it. Every single one of these decisions you put into making a pot reflects your worldviews, your culture, how you grew up, how you learned to do things. So by studying this, we can get a lot of insights into past populations. And on the right hand of the screen, I have some of the bigger questions. So a lot of these on the left side of the screen are common and a little bit simpler data-wise to understand. But what was it used for? And did it serve multiple purposes? Was it specialized? And how was it used? There's only a few ways to get direct evidence on such a thing. And thanks to decades and decades of research from those who come before me, a lot of these other questions have been asked before I even got interested in the subject. So thanks to that, I'm able to answer some of these bigger questions, like how was it used for and what resources were used. Pottery is one of these really interesting technologies because it's an independent invention. It's one of these things that humans created that happens all over the globe. So we see pyramids, math, language, different technologies, stone tool points that are used all over the globe. And a lot of it is word of mouth carrying, adoptions via proxy of these uh, knowledge and technologies being passed, but a lot of them were independently adopted. And in this map here, I show this image shows some really early pottery types made by hunter-gatherers and sort of the spread and timeline of pottery adoption globally. And I'm going to turn on my laser pointer here. And here you can see some of the really early pottery is being made in the American Southeast, and that's exactly what I'm studying. So way back in 1936, V. Gordon Child proposed this idea for the adoption of pottery in the Fertile Crescent in Europe. And his idea was that pottery was one of these technologies that hunter-gatherer societies needed in order to settle down, stop moving with the seasons, and start living in villages and getting into agriculture and sort of those trajectories for what he calls evolution of civilization. So pottery is one of these technologies that allowed people to store and process big quantities of foods in order to support bigger populations that are becoming more settled. And that hypothesis works really well for the Fertile Crescent, the Mesopotamian area, but there's areas all over the globe, and here we are many, many generations, later, and we've discovered that hunter-gatherers in many regions across the globe, especially in these northern hemispheres, the northern hemisphere, were creating pottery and not settling down. So everything you see here, these are mobile hunter-gatherers that adopted pottery and remained mobile for quite a while. And with the adoption of organic residue analysis, uh, where you're able to directly determine what was processed in these pots, Gibbs and colleagues came up with this idea based on data that they were finding of an aquatic Neolithic. And this is a play on Child's uh, Neolithic revolution, where instead of pottery being associated with agriculture and settling down, pottery is often associated with shellfishing and fish. So a lot of these early pottery sites have large shell rings or middens or large accumulations of shellfish. So there's this idea that pottery allowed people to exploit mass quantities of fish and shellfish. And finding early pottery in the context of fish and shellfish remains is certainly true of Stallings wares in the middle Savannah River Valley and along the coast of Georgia and South Carolina, where there's many shell rings, and this is where this really early pottery is found. So that begs the question, was this pottery used for fish and shellfish? That's certainly the context that it's found in. So here we are at a map in my study region, and this shaded gray area. This is the primary distribution of this early pottery found among the remains of shell. And so the earliest stuff started here on the coast, and then here's the Savannah River Valley, this right here. And you can see this sort of spread of this innovation going up and down the river. So the early Stallings phase, this is when the earliest pottery hits the scene, and these are these shallow, flat-bottom basins with really wide orifices, and the majority of these are plain. And these are really well suited for what is called stone boiling or indirect heat boiling. So instead of cooking directly over fire, you're heating up rocks and then dropping those in the pots in order to boil. So you'll notice once we get over here to the classic Stallings period, we see a shift in pottery. So this shift in pottery goes along with a shift in lifeways. So these populations are becoming increasingly settled. They're living in small circular village centers, and they're storing they're storing their food in a little bit different ways. So as we'll see coming up here, we go from a communal storage to more of a household-based storage. So a lot of the households that we see with these sites have their own storage facilities. It's much less communal and more house-based. So you'll see during the classic Stallings period, we have this shift in pottery. So it goes from this flat bottom basin to these more hemispherical bowls that have taller walls and a little bit more constricted orifice. And these are much more well suited to direct heat boiling. This rounded base is more ideal for nestling in the coals of the fire. Just the overall design of this is well suited for direct heat boiling. And that is certainly how it's used when it pops up on the scene along the coast. But interestingly, and tied to the specific cuisine and cultural use of the Middle Savannah River Valley, no pottery from this time period in this region has any evidence of soot, which is a telltale sign that those pots were used directly over fire. So here we see a shift in lifeways, a shift in technologies, but a traditional use of pottery using these soapstone cooking slabs. And coincidentally, soapstone really outcrops along this fall line. So right here in the middle Savannah River Valley in the lower Piedmont is where this raw material comes from. So it seems like folks in this area are really tied to this and tied to these traditional cuisine values. And here's a little zoom in of the particular area that I'm studying. You can see here in the middle, Stallings Island, the namesake of these sites. And in total, this is 4 sites that are under study here, and they cover both early Stallings and classic Stallings phases. And here's some photographic examples of stone boiling. And you'll notice that in none of these examples do I show pottery. because stone boiling is something that you don't necessarily need a pot for. You can dig a hole in the ground, you could and boil. You can use a hollowed out tree stump and boil, or you could use an animal skin and boil. But and this is how boiling was done prior to pottery, but interestingly continued to be used for this once pottery hit the scene. And here's a little slide on some of this, macroscopic remains that we know from Stallings Island. And this again is research that came before me. But we have all kinds of evidence for fish, fish, terrestrial animals, not so much plant remains, but there is hickory, acorn, pawpaw, and some persimmon. And then we also have these subsistent technologies beyond pottery. So we can tell a lot about the subsistence practices that are happening here and, can make some inferences about what was being processed in these pots. But ultimately, that's not direct evidence for what was processed in a pot, because you could have a whole lot of food in your cupboard, and that's not necessarily what you're processing in your cooking pots. So one of the only direct evidence that we can get for what was actually cooked in the pot is to take that pot and do a chemical analysis in order to determine what was being processed in it. So this was sort of the stimulus for my dissertation research. I was interested in what specific resources were being processed in these pots. And did pottery use change over time? So the Stallings period, encapsulates this period of time when we have hunter-gatherers moving with the seasons, and then the classic Stallings period where folks are starting to settle down. So I was interested, does settlement patterns affect the use of pottery during this period of time? So how do absorbed residues form? Absorbed residue analysis or organic residue analysis is primarily the analysis of lipids, which are fats and waxes. And just about everything has these in it, even if you took your thumb and pushed it against the side of pottery, there would be some residue. I don't know if it would be picked up on, but just about everything has these lipids in it. So it's a great thing to analyze because it's going to give us a lot of information. And boiling, thankfully, really helps the release of these molecules. So heat and water play a big role in mobilizing these lipids. And as food is being processed in these pots, those molecules are getting broken down, and the water is helping it seep into the body, the matrix of these sherds. And another great thing for organic residue analysis and Stallings pottery is that Stallings pottery was tempered with Spanish moss. So when it is fired, it leaves these really large holes. Well, not large, but it leaves these vacuoles in it. And this is a great way for molecules to get stuck and absorbed and preserved for a long period of time. This isn't an asset when it comes to using a pot, an untreated pot directly out of a fire. This does cause porosity issues. So this is something to consider in the future when we're thinking about the manufacture of these pots. And this is something that they had to overcome, was the porosity of these. But it worked great for me because it really held on to these lipids that I'm trying to analyze for thousands and thousands of years. And then getting these lipids out of the pot, I'm gonna not get into the details here, but basically you grind off the exterior of your sherd. You've got a small sample and you grind off the outside of it. And you do that to remove any contamination. So like I said, just if you put your finger against this sherd, it has the potential to absorb lipids just from your fingerprint. So by using a Dremel and sanding off the outside, it really reduces the amount of contamination and modern contaminants that can get into those pots. So after you grind off the outside, you crush up that sherd and then you throw a mixture of chemicals at it in order to suck out those molecules from the matrix of that pot. And you can see over here, this is mid-process of trying to extract those molecules. And you can see right up here at the top is some of these lipids starting to come out, and down at the bottom is that crushed up pottery sherd, that matrix that we're trying to sort out and get out. And what you end up with is a very small, this little vial is probably 2 centimeters tall. So it's really small. You don't need a lot, and you end up with just this pure lipid extract. And one thing I found as I was doing this is that you can see that this one's a little bit yellow and they're a little bit more clear over here. One thing I discovered is that the more yellow the color, the more lipids were in that sherd. So I started calling these yellow extracts really juicy sherds because I knew we were going to get a lot of data out of that. And after you extract it, the way that it gets analyzed is with this beautiful machine called a GC mass spec, or a gas chromatography mass spectrometer. And essentially, after you inject this into the machine, it goes into this little unit right here, which is pictured up close and inside here. And this is a vacuum sealed, vacuum pressure, and it's heated up. And you'll see this coil right here. This is really small tubing. And so as you inject that extract right here, it starts going through this tube and it spins round and around. And as it's going, it's getting heated up and it's getting pressurized. And we're trying to put as much pressure on these molecules as possible, because as those molecules break, the moment that they break is how we know what molecule it is. So you'll see over here, sort of on the data collection side, you'll see time retention. So the moment that molecule breaks apart is how we know which molecule it is. And this right here is sort of what the raw data looks like. As it's coming out the other end, these spikes are where those molecules are breaking apart. And a little bit about sampling. I don't want to stay on this too long, but these are the 4 major sites in the Middle Savannah River Valley that I'm studying. And 2 of these sites have early Stallings components, and 3 of them have classic Stallings components. So Victor Mills and Ed Marshall have those early Stallings components, and then both Mims Point and Stallings Island, particularly Stallings Island, have those circular village compounds. So we have evidence that people were living year-round or essentially year-round in these 2 areas. Whereas it, particularly Victor Mills, this was a seasonal encampment where people were visiting for maybe 2 weeks out of the year or maybe a month in order to gather resources seasonally. Now, one of the important things on my sampling strategy that I do want to touch on is the fact that I didn't just take 1 sample per vessel. And this is sort of unusual. You don't want to waste your precious sherds, and you want to save as much as possible. But I did do something what I called serial sampling, where you take multiple samples per vessel. And I did this because studies back in the 90s, when organic residue analysis was really hitting the scene, they did this multiple sampling strategy to look for where these molecules were getting absorbed. So where these lipids were getting absorbed in the profile of the vessel. And by profile, I mean top to bottom. So they found in their archaeological studies that most of those lipids were found at the top of the base, and then it decreased towards the bottom. And then they performed an experiment with replicated vessels in order to compare what they were seeing archaeologically to an experiment. So they experimentally did simulations boiling cabbage, and you'll see here on the left-hand side is the result of that. And this pattern of accumulation matches the archaeological evidence. And after doing this, they saw this pattern, and sometimes this pattern is used as a way of determining the function of the pot. So if you were to do organic residue analysis on an archaeological vessel and you saw this pattern, you could pretty confidently say that that pot was used for boiling. Now, Before I get into the results of the organic residue analysis on Stallings pottery, I do want to spend some time tempering your expectations because I spent a couple months coming to the realization that organic residue analysis isn't a quick fix. It's not going to find exactly what you want. It's not going to answer all the questions you have. And that's mainly because only so many resources out there have unique, what's called a biomarker. So a biomarker is a chemical signature that's very specific to a specific resource. And that doesn't happen very often. So a lot of the times we're using ratios of these different chemicals to sort of determine, is it this resource, is it that resource? And ultimately, the three main resources that you're able to tell is plant, fish, and terrestrial animal. Now, when it comes to plant and aquatics degrading over 5,000 years, it turns out that plant and aquatic are pretty difficult to tell apart. Now, I do want to say that the technique that I used for this was one that captured the most information. I could go back and there are more specific techniques, isotopic specific techniques where you could get down to more specific resources, but what I chose was the broadest so we could get the most information possible. Now, in the Southeast, with this particular case, plant and aquatics were pretty difficult to tell apart. So when we get into the results, you're going to see categories that are plant and or aquatic. And that's what we're going to see here. So here's the results of the early Stallings samples, and these are those flat bottom plain vessels made by mobile hunter-gatherers that are traveling up and down the Savannah River Valley. And here we can see that about 63% of these pots were used for processing majority plant and or aquatics, and only 7%, three of the vessels here had a strong terrestrial animal signature, and only 5% had a strong plant signature. And then you can see that the remaining bit here, other than the uninterpretable, 24% of these were mixed. So it had a pretty even disbursement of all these markers in it. Now, how does that compare to the classic Stallings? Well, there's not much of a shift here. Pretty similar percentages. Maybe a little bit more mixed, fewer plants, more terrestrial animal, but pretty similar in the plant and or aquatic range. You'll see that the number of uninterpretable residues jumped up quite a bit from the early Stallings, and that is majority in part to samples from the Mims Point site. So a number of these samples, not all of these, but a number of them had hopanes in them, which is evidence of some sort of fuel leak. So it seems like there was some sort of contamination where either oil or some sort of natural gas was seeping into the soils and got into the pots. So that number of uninterpretable jumped way up. But you'll see here with the interpretable stuff that these percentages are pretty in line with what we were seeing in the early Stallings phase. No big jumps, no big statistical differences. So what does that tell us with these general trends? And that's not looking at anything specific yet. That's only comparing early Stallings pots versus classic Stallings pots. Well, what it tells us is that there's a great diversity in what they're cooking. It's not specialized. And it's certainly not an aquatic Neolithic. Not with some of these other studies done by Griggs and what Griggs gives us talking about. These come from Japan, Russia, China, in other areas, and the results are overwhelmingly aquatic, and that is certainly not what we're seeing here. Not that aquatics weren't a really important resource for Stallings culture, but it is telling us that these pots weren't specifically designed and made and adopted to process fish and shellfish solely. Now, how can we narrow in on some more detail here? Because those categories aren't necessarily as satisfying when you're trying to understand what resources are being cooked in these pots. So next I'm going to jump into two examples, site-specific examples, in order to get some better context on what these food resources might be. So first I want to talk about Victor Mills, and this is one of my favorite sites This is that early Stallings encampment. So they were probably staying here for short periods of time in the fall. And there's a lot of evidence for hickory nut processing. Excuse me, I want to take a drink here. So these early Stallings groups that were living on the coastal plain and maybe even the coast were traveling upriver into the middle Savannah River Valley to what looks like purposefully and harvest, process, and store hickory nuts. So there's a lot of evidence for there's charred hickory nuts, and I also see up here all these pits. So there's many pit features here, and some of them look like processing pits, some of them look like hearths. And some of them look like storage pits. And you'll see here, we even found this really large anvil laying right on top of one of these potential storage pits. And I also want to speak to the shell midden that's at this site. So there is a small shell midden here, but it doesn't look really compact, and it doesn't look heavily used. So it looks like these are is the discard of daily meals. They were obviously eating shellfish that when they were here, but it certainly doesn't look like they came to this site in order to explicitly harvest these shellfish. And another thing we find here is the remains of white-tailed deer. So it seems like this was a camp where they would come into the fall zone, where hickory trees really bloom and where they start to come up. It's more pine in the coast and coastal plain. And then we get into those oak hickory forests once you hit the fall zone. So it looks like they were coming here to hunt deer and harvest hickory nuts. And when hickory nuts fall, happens to be at the same time that the deer rutting season starts. So these two resources really combine, and this is a great area to exploit these resources. And you'll see in the pie chart over here that this plant in our aquatic category really shot up. So we're at 80% for the 32 vessels that were studied here. And only 2 uninterpretable, which is great, but pretty similar, 2 mixed pots, 1 plant pot, 1 terrestrial pot, but this plant aquatic category really jumped up. So what resource in this, plant and or aquatic, that could be a lot of different things. So what were they processing here? Well, it seems like hickory nut, because that's what we have the evidence for, but plant remains don't really preserve in the archaeological record very well. Another thing we can look at is the accumulation of those lipids, right? So you'll see here, this one on top is one of the pots that I did a multiple sampling on, and you can see not only the different sort of accumulation pattern here, which I'll get into later, but check out this number right here. That's 2,000 nanograms of lipid per sherd, which is unheard of. That is really a lot. You can see here, looking at the simulation from this cabbage study that was done. This is a modern study. It was done in 1993, so you would expect there to be more lipids in there. So 2,000 versus 262. This tells me that there's something really fatty being processed. And if we look at the percent of lipids per weight for some of these common resources that are processed in the middle Savannah River Valley, hickory nuts is top of the chart, bar none. There is no resource that I'm aware of that has more lipids than a hickory nut. So this is just some evidence that points us in the direction that they were processing extremely fatty plant resources. You'll see if we compare this to more of the aquatics, that lipid percentage drops way down. And then let's look at the hemispherical bowls found at Stallings Island. So the bar graph here, what stands out is the number of mixed. So the number of mixed pots really goes up, and the plantain or aquatic goes a little bit down. But I do want to talk about 2 pots in particular, which came from unique contexts. So these two pots that I'm talking about here came from a feasting pit. So this is feature 17, and it has great evidence of a feasting event because it's filled chock full with animal remains that were put in there really quickly, which is evidence that some sort of massive food eating and discardment happened over a quick period of time. And interestingly, two of the most unique chemical signatures in this study came from feature 17. So these are these biomarkers that I was talking about, these two unique resources. So one of those came from a dandelion, and the other one was castoreum, which comes from the anal gland of a beaver. And I gotta tell you, never in 100 years did I think that I would be standing or sitting in front of a group of folks interested in archaeology talking about anal glands of a beaver, but it turns out that there's some really interesting history going on here. And castoreum is one of these aromatic and flavorful ingredients that's found in a number of things. So one, it's found in a lot of perfumes, and that's sort of that aromatic. And two, I found out that it used to be, I don't know if it still is, but it at least used to be used as an ingredient in vanilla extract. So these are two pretty unique signatures, and the castoreum I found particularly interesting because that hasn't been found anywhere else in North America, and all of a sudden in this really unique context, we have this pretty unique biomarker. So going into this study, I had this idea in my brain that as groups settled down and started living in one spot, they were place-based, I thought that pottery would become more specialized. In my mind, we got early hunter-gatherers that are moving with the landscape, and we have evidence from petrographic studies and that these pots were moving around the landscape. So people were bringing these pots with them into the middle Savannah River Valley. I thought that those pots were probably more multi-use. They're bringing this one technology with them, and they would need to use it for a number of things as they moved around the landscape. And I was thinking that classic Stallings pots would become more specialized as they became more familiar with this place-based living and specific resources, processing specific technologies. Well, that wasn't the case. It's sort of the opposite. And if anything, the vessels are becoming more diversified as communities were becoming increasingly settled. So that's sort of the opposite, but it's good to have these hypotheses, right, that we can test and disprove and move the conversation about prehistory forward. Now, another major component of my dissertation work was experimentation. So, like I was telling you about that study with the boiling cabbage in 1993, they were able to do these modern day simulations of ancient cooking techniques using resources that we know are in the archaeological record. And they're able to use that as sort of a reference point for comparing your experimental residues versus your archaeological residues. So I performed a number of experiments and did organic residue analysis on those replicated pots in order to compare that to the archaeological data. Another reason I did this is I was interested in masking and masking of food resources. And this is a word that's used when we're talking about a chemical signature dominating something else. So as you might anticipate, a really fatty food might dominate a lipid or low-fat food. So I was interested in seeing how that sort of played out with different food resources that are common to the American Southeast. Again, every single experimental study that has been done with organic residues all takes place in the old world, so outside of the Americas. So we didn't really have any experience or knowledge for the types of foods that were being processed in the southeastern United States. And interestingly, hickory nuts aren't really a big thing in Europe and Russia and places like this, where they're fatty, so they don't have that really fatty plant signature in their pots. They usually anticipate that fatty animals are outwearing their plants, whereas in the southeastern United States, it looks like the plants are actually dominating those animal resources. And then the third question, I was looking for that pattern, that absorption pattern for does what does indirect heat cooking look like in that profile of the vessel. So all the experimental work that has been done using replications and organic residue analysis, those were all done with direct heat cooking. So I was interested in comparing those lipid absorption patterns via direct heat and indirect heat boiling with soapstone slabs. So I performed an experiment that looked at both of those types of cooking functions, and I had four of each. So you'll see over here on the right side are the hemispherical bowl replicas that I used in direct heat cooking, and then these more flat bottom shallow basins that I used in indirect heat cooking. And this was 4 episodes, 4 pots for each. And in these, I cooked those major resources. So plant, terrestrial, animal, aquatic, and then that fourth one, I did a combination. With that combination, I was hoping to get at some of those questions regarding masking. So here's some images of vessel replication, and you can see here some of the different processes that went into this. You can see the shredding. This is the Spanish moss that really needed to be dried and cured and go through a sort of a shredding process, and I'll talk about that in the conclusion in a little bit. And the recipe for how these pots were made, the recipe for what was going into it, but also the shape and design was all based on archaeological studies. So the proportions for what was going in here, that came from a paper done by Zach Gilmore, who studied the composition of these pots. And then the form, I took these from Ken Sassman's work, whose dissertation was on the Stallings culture in the Savannah River Valley. So both the recipe for making it and the form were based off of archaeological finds. And I wanted to show this because when you do experimental archaeology like this, you have an option to do it in the lab, which most people opt for, or you can do an actualistic study. I went the actualistic route just because I figured, these Stallings populations weren't cooking in a lab without external environmental factors. So I wanted to get something that was close to the actualistic results as possible. So I did this outside at the University of Florida at the Southeast Lab. We dug sort of this really shallow trench and used that as sort of our kitchen, cooking area. And here, I'm going to show you what that stone boiling looks like. And hopefully the sound isn't on, otherwise you're going to hear Ken talk about Korean barbecue. But regardless, this is pretty cool to watch and really interesting. So you can sort of see the different levels of boiling there. You can get a really soft boil going, and then after you add one of these hot rocks in, you can see that really big boil going, and you can see the soapstone slabs that I was using right here on the side, and some in the fire. So I was taking them out of the fire and putting them in there. Okay, so to the results and what I learned from the experimental stuff, and a lot of the things that I learned from the experimental study isn't related to organic residue analysis. So you learn a lot just by getting out there and doing it, and just getting some firsthand experience with it. So first and foremost, I knew porosity was going to be an issue going into this because these things are just laced with holes. So I knew that these were going to be essentially be like terracotta, potting pots for plant pots where water is going to seep through it almost immediately. And that did happen. So here's vessel one. This one didn't get submitted for organic residue analysis, and that's because it got so seeped with water here. But because I knew this was going to be an issue, and because I did a pilot study that determined that there was pine resin in these pots, I had pine resin on hand to coat these and seal them so that this wouldn't be a problem for the rest of the study. And as soon as we applied this pine resin to these pots, it really resolved that issue quickly, and we're able to get a boil going pretty quickly. And here's a picture of me pretending to smile, but I am actually quite sad inside, because this pot, you can see sort of this water seeping through. And when this happens, it really puts a halt to what you're doing, because you cannot reach boiling temperatures if the vessel is soaked. But that's all right. We learned, we moved on, and applying that pine really helped and really got us going. So I sampled these, much like the archaeological stuff. I took 3 samples from each vessel, from the rim
Mm-hmm.
body and base, in order to get a look at those accumulation patterns. Like I said, in order to compare that to the archaeological absorption patterns. And here's some really lovely data that I'm not expecting you guys to read, but what I do want to zoom in on here is the results of some of these experimental stuff, and this gets to the question of masking. So you can see here on the left-hand side, these were the resources actually processed in these pots. So here we've got the aquatic pots, we've got the terrestrial pot, and we've got the combination pot. And here's the result of the organic residue analysis. Now, when you do analysis like this, you do it blindly, so you have no idea which pot was used for what. So this is all just, interpreting the data raw with no bias, or hopefully no bias going into it. And what you'll see here is primary plant, primary plant, primary plant, primary plant, primary plant, primary plant. And for a number of these, in fact, everything but the combination pot, a plant was not being cooked in that pot. So this brings up the question of pottery sealant. So if they were using that pine resin to coat these pots, that is clearly what's dominating our experimental study here. So that begs the question, when we find primary plant in the archaeological samples, is that the sealant? Now, I will say that the archaeological samples that I did for this bigger project had far fewer biomarkers for that pine resin than the pilot study. But the pilot study, I think it was something like 40% of them had that biomarker for pine. And once I did the larger study, that went way down. So this question of, is the sealant masking what was actually cooked in there? That's a question that is particularly interesting when you have that biomarker for pine, because if that pine was used as a sealant, then we can start to question, well, is that what's dominating the other signatures that we're seeing in this pot? Now, some other insights that we gained from this was the length of the temper. So my wonderful father is the man who designed these pots and was the real craftsman on this. And he discovered that these long fibers, when you find Spanish moss in the tree, it's got this really long hair fiber. When you use that as a tempering agent, those fibers become extremely knotted in your wet clay, and as you go to fire it, those pots almost always cracked. So we found that the shorter the fiber, the better it worked as a tempering agent, and it would crack far less often. Another thing that struck me about these was the weight of these pots. These are really big pots. You can't carry 2 at a time. They're pretty big, and they're pretty heavy, and weight isn't necessarily a good measurement comparing modern to archaeological. But I do think it's interesting because a wise man named James Spivo and Eric Schiffer once proposed that fiber tempered pottery, so pots tempered with fibers like Spanish moss, maybe it was done that way to reduce the weight and make them easier to carry. But one just sort of side note is that I noticed is that these pots were quite heavy and not easy to carry. Another thing that I learned going about this is the number of those soapstone slabs that you need. So going into the study, I didn't really know how I was just guessing that we would need about 4 to 6 soapstone slabs per pot to get a boil going. But on average, we needed about 16 slabs in order to boil foods in these pots for 20 minutes. And so the hotter those slabs were, the better. So I was shooting for taking those stones out of the fire at something above 500 degrees Celsius. Another thing to note is that indirect heat cooking happens really quickly. So if you have a fire going all day long and you have these rocks in the fire, you can throw them in your pot and you can get a boil going almost immediately. Whereas with direct heat boiling, you put your water in a bowl, you put that bowl over the fire, it took upwards of 30 to 40 minutes to get a boil going. So that did take longer. But with indirect heat cooking, you really need to be attentive. You need to be cycling those rocks in and out of the fire, poking around in the fire looking for the hottest rocks. Whereas with direct heat cooking, you can sort of step away. You can leave it on the fire, step away, and come back. And then we just talked about masking and the possibility that North American plants that are really fatty and dense with residues like pine resin or hickory nuts, those have the potential to mask less fatty things that we see in the archaeological record, like white-tailed deer. And then again, vessel porosity. It seems like some sort of sealant would be necessary for these. That might have been just be like you season your frying pan or your cast iron. You just need to cook in it a few times in order to get it sealed off. But there's that possibility that they were using pine resin. But one thing I do want to mention is just because we find pine resin in the pots doesn't necessarily mean that was being used as a post-firing treatment. It could be that they were either firing these pots in pine fires or they were cooking using pine, because as that pine heats up, it can shoot that resin up into your pot and it can be absorbed into your pot. Okay, that is it. Thank you. Many thanks to, all the people that went into this, especially my dad, my family that supported me through this, and Ken Sassman, whose shoulders I stand on when it comes to background information and just inspiration behind this entire project.
Thank you so much, Emily. Excellent talk. Love the beaver at the end. So yeah, we'll open it up for questions. If you prefer to type them in the chat or feel free to unmute and ask your question.
I've got a question.
Yeah.
So are you assuming that anything that was basically cooked in the pot throughout its use life would show up in your analysis, or is it only things that are like cooked towards the end of the pot's use?
It's the entire life history of the pot.
Cool.
Yeah.
Sue asked, what was the cat doing in the moss?
That's a really good question, and I'm glad you asked it. It turns out my cat is addicted to Spanish moss. As soon as that stuff hits the floor, she's more than catnip. It's absurd. No, my cat is absolutely obsessed with Spanish moss, and I tend to have to do any work with Spanish moss at the lab and not at home now.
But any other questions for Emily? Excuse me, for Dr. Bartz. You earned that title.
Emily, can you hear me?
Yeah, I can.
Great. what are you cooking in this pot? Is that lunch? What are you cooking here? And is it
In
edible?
this picture here?
Yes.
Yeah, so those are leafy greens. So these are going to be dandelion greens and mustard greens. Yeah, everything I cooked is edible and the experimental stuff. I
Hmm.
tried some of it and not all of it. I'm not going to say that I was out here making exquisite meals. I was just trying to get data on this one.
Oh. I don't know if I would eat stuff out of a pot lined with resin and pine resin and those items. I don't, is that safe?
Oh, well, yeah, I did, and I'm still kicking. Yeah, it definitely it left a smell. You can still smell that resin on these pots for sure. And you can taste it. It reminds me of frankincense. It smells like Christmas. Um, I would not say that it ruined the taste of it. I don't it was just sort of a piney tree nutty taste.
Okay.
Bonnie, it looks like had a more of a comment. She said hickory nuts tasted like weird oatmeal.
Yeah, so yeah, I've continued to do some cooking with hickory nuts. In fact, I did some just last weekend, and it tastes a lot like oatmeal, like a lot like oatmeal.
Sue in the comments asked, is there any other sealant that could have been used by the Native Americans?
Yes, absolutely. So like I was saying, you could just season the pot. So you could just cook a well, not cook because it wouldn't may not have reached a boil, but you could coat it with anything really fatty. I've also done a unofficial experiment with duck fat. You could do it with bear fat. Somebody suggested deer brain to me one time. There's a number of things you could do to seal these pots off.
Very cool. Any other questions? All right. Jamie, should we? Oh. Dandelions are European. What related species were they using?
Related species to dandelion. So there's a number of these types of things don't really preserve in the archaeological record. The signature that I was going for here was leafy green. None of the I wasn't expecting to get biomarkers from any of this or down to the resource with any of this. I was just looking for what leafy greens look like. And that's why I chose these resources here.
That makes sense. All right. So thank you.
All right. Well, it looks like we don't have any more questions. So I just want to say thank you again, Emily, and thank you all for joining us tonight. Appreciate it. Great talk.
Thank you.
All right. Well, thank you. Everyone have a great rest of your Florida Archaeology Month or Arkansas Archaeology Month, whichever applies. And hope to see you soon.
Okay. Thank you. And thank you, Emily.
Thanks.
Thanks, guys. Have a good
Everybody.
one.